Of course, that includes journals and commitment control as well. Those all are part of the IBM operating system's official version of DB2, relational database. But over the years, I have realized that when you're modernizing an application, you need to separate the actual I/O functionality. Take it out of the program and put it in between the application programs and the database. So I created a thing called an I/O server. I called them I/O servers. And they are input-output services. And the way they work is this. They have numerous benefits. Numerous benefits. And so let me explain how they work. We have an application program A that wishes to write, update, or delete a record from table A. So what it would normally do is it would issue the request to the relational database management system, and all triggers and constraints being satisfied, which is always a proviso on this lot, that request will be executed onto table A. And the triggers, RDBMS, and everything else would return back to application program A an acknowledgement that their request was successful. In fact, it doesn't get an acknowledgement that the request was successful. It just gets sent back absolute silence. They get shouted at when it doesn't work. That's the way of the thing. Then application program A, oh, by the way, that particular request has created, where this arrow sits here, has created a thing called an open data path. It's opened a data path to table A. It has created a file definition table in the PAG. So when program A calls program B, and program B also wants to do some sort of interaction with table A, that creates a second open data path. Unless you go to the trouble of doing a database override. Again, while I was developing the I/O server concept, I began to realize that these overrides were complicated, they were difficult, and they created issues because in some cases they happened and they worked properly, in the other cases they didn't. So this was part of the thing process. So here I've got open data paths. What happens, of course, when you have two open data paths, in your PAG, Process Access Group, which is an object that is assigned to every job that is opened on the IBM I, and requires to be in memory for the job to do anything, will, because there are two open data paths, will get two file definition tables, two file buffers, and two file record pointers, which doubles the PAG, or doubles the space used for that particular one table, which you want to avoid. The other thing is this application program B has to go through the open data path, the file open the second time. This one opens the file, this one opens the file the second time. So not only do you have excessive PAG usage, but you also have the overhead of having to do an actual file open twice, all for the same program. Now, modernizing your application code, you often get this situation where program A will, for example, read a record out of the file, pass control to program B, which will update that record. Now, that means application A will do a read to get the record, pass control to application program B, Application program B will require to do an update, so it will have to do a read before it can do an update. And it gets very complicated. So the concept of the I/O server is as follows, and this is basically the change. We create a RPG object. This I/O server is an RPG module. It can also, if you absolutely insist, it could be a SQL module, it could be a C module, it could be any other module written in any particular programming language you like, because we are in an ILE environment. However, I use RPG and only RPG. The I/O server is then the conduit to the table. So application program A will pass the request for whatever it wants to the I/O server, who will then check to see whether the file is open. If not, it'll open the file, it'll pass the request through RDBMS to the table, it will receive the response, of course, based on, let's go to the big picture. Any before and after triggers will take action at this particular point through RDBMS, and the control will be returned to the I/O server that initiated the call. There are multiple. What I tend to do is I tend to have one I/O server per table, a one-for-one relationship, because otherwise you have too much conditioning and too many issues. Sorry, I'm hearing things bleep and so on and so forth, so I just want... Okay. So, let's have a look at this. I/O servers act as a sort of border patrol. What you are doing here is you are separating the actual job of input-output from the application. So the application no longer directly does input-output to the table. It does it through the I/O server. Now, this can create a number of benefits, and let me itemize them. The first benefit is that the I/O server can then be used to contain information or contain processes that are applicable to the input or output to or from a table. And that's an important consideration, because that is code that is written into the I/O server. It's written into the I/O server, and it behaves in a similar way to the other service program procedures we were talking about. You write a particular behavior for a particular file or particular table. You write certain behaviors relating to I/O on that table into the I/O server, and that means they do not have to be written into the application program. So once again, you are devolving, shall we say, certain actions that need to be written there and there. You're devolving them to a single place, the I/O server. I will show you clear examples of how this sort of thing works. I'm just trying to give you an overview of the picture. So, common code that relates to the input-output services for a particular table can be written into an I/O server. A simple example would be a customer number. If the insert function requires that a new customer gets the next number in the list, which is pretty common, that process can be done inside the I/O server to actually go and fetch the next number that's to be used, added to the record before the record is written to the table. Now, all of you are probably, I hope, thinking, oh, that's interesting. Why don't we do that in the before trigger? Because you can actually change records in the before trigger, so why not add a new number into the before trigger? No? Okay. The reason for that is that the record, the actual record that is being inserted by this program, is passed to the I/O server. That record is shared. It's an import-export situation. So that record is shared by the I/O server and the program. When the I/O server adds the customer number into that record, inserts the record into the table and returns control to the application program, the customer number is available to the application program because they are sharing the record structure. If you do that function in the before trigger, which you can do, you can in the before trigger add one to a data area which contains the last customer number used, and you can put it into the record and it will write it to the file. But that record is not then available to the application program. So in order to retrieve the record that program A has just written into the table, program B would have to chain to the table to get the record. But program B couldn't chain to the table to get the record because program B doesn't know what the customer number is. Whereas the I/O server has a common area, has a common record between program A, the I/O server, and program B. So the information is available to all three of those objects, which is why we do that type of behavior in the I/O server rather than in the trigger. There's another thing that is, to my mind, probably the most important thing about an I/O server and its functionality. I'm going to ask for a quick demute for all those people who have their entire database protected by a public exclude authority. If you have, please switch off your mute. I'm talking about every database file in your database is protected by a public authority of *exclude. Okay, I got no takers, which is not a surprise. If you have a public authority on any table in your database other than *exclude, you are at risk because SQL clients have access to your table. You then have to go to the extremes of authorizing or deauthorizing individual user profiles or groups of profiles to the table or tables that make up your database. Now, in the case where I/O servers are handling the I/O to the database, the I/O server is a program. It adopts owner authority. The owner of the I/O server is the same person who owns the table. And the table says public exclude. So the only person who can touch that table is the owner. But the owner is not a logon profile. And the only programs that have that profile are the I/O servers, and they adopt the owner profiles. So basically, the tables have public exclude, and the only program that can access those tables is the IO server. Which means that if anybody tries to access your database through an alternative SQL client, they will get rejected as not being authorized. The only thing that can access the table is the IO server. But the IO server has to be properly called from within an application program. The IO server has a public star use, and it has to have an application program calling it and passing it the correct parameters. So it is almost impossible for a SQL client to utilize an IO server, because IO servers are written in RPG and SQL clients don't directly access IO servers programs. So what you're doing is you're creating an incredibly high level of data security by shutting down access to your database and allowing official applications unrestricted access through the IO server. And this is honestly probably the most serious consideration for IO server development, is that there's no other way to protect your data from unauthorized access without a large and hugely complicated access definition system. Just to give you an example, I worked for somebody in South Africa numerous years ago. I was teaching Query 400 to their users. And I said to them, look, I need access to a database so I can demonstrate how you build queries and how you read them, and I need access to this database. And they said, all right, they think that the best database is the personnel database, and they would give me access to it. I said, that's super. Can I come in tomorrow and do the training? I mean, when can I do the training? They said, no, unfortunately, it's going to take us a while to give you access to our database. So you have to give us 2 weeks. I said, 2 weeks? They explained to me that, yes, first of all, they have to put in a request, and it has to go and get authorized and signed off, etc., etc. But then their access control person had to sit down and had to put my name and my authority on every single one of their physical database tables in that database, individually, one at a time, in order to give me access. And that would take him at least 3 to 4 days. And I thought that is the wrong way to protect your data. And all of these things led to this IO server, where you go through your entire database and you make all the tables public exclude. Obviously, you won't do this, otherwise your existing application will crash, and you will have a great deal of pain. But you create an IO server, you find out who is using that table, you convert those programs to use the IO server, and then that table can be switched to public exclude. So you never do these things in a big bang format, because that's crazy. But you can do it one file at a time, one program at a time, it doesn't matter. The important thing, and I think right at the top of this whole process, I gave you a quote from Alvin Toffler that says one has to have a picture of the direction in which you're going, so that when you get to do all the little things, like IO servers, they all go in the same direction. You don't want everything to go in all sorts of directions. And this is the whole point. You adopt a philosophy, it doesn't have to and can't be done this week. It's just not possible. But you can always work towards the philosophy which says, if I have to change something, I must fix it in line with the long-term strategy for modernization. And one will actually be surprised how quickly that happens. And then, of course, as things get better and better, your programmers are sitting around doing nothing because everything is working so well. You can get them to pick up another program or another file and do an I/O server for that and triggers for that. And so the whole thing evolves faster and faster and faster. But the potential for an I/O server to protect the data in your database from unauthorized access cannot be stressed enough. Also, of course, your PAG only has one open instance of the table A. And as long as you keep using that one I/O server, application programs, service program procedures, everything that uses that one I/O server all use the same open data path. So you reduce the size of your PAG. You don't ever have to worry about doing overrides, because if you use that I/O server, you are using the same open data path, obviously in the job. If you open that I/O server in another job, that job has its own data path. So by using the I/O server, you're channeling everything through a single data path. It may sound like it could have a problem, but it doesn't. Because again, most of what we do here is interactive, and as I said before, the time between the user pressing the enter key and looking up to see what's happened on the screen is a century as far as the processor is concerned. And transaction processing in batch, as I said earlier, we should be trying to get rid of, but batch processing is sequential when it's processing a data table, so it keeps using the same open data path sequentially. So I/O servers don't even have the same problem as triggers. They don't add an overhead. They do things on the way through. Okay, this line here is then basically the barrier, the border between the application and the database. And the I/O servers act as the border control. They manage the access of the applications to the database under control of the I/O of the triggers, both before and after. And the I/O servers may react to a particular trigger issue on behalf of the application, i.e. the I/O server may not even let a particular problem get back to the application program. It may fix it there. We'll have a look at some examples. Any questions so far? Yes, we have got some. Don't you still have to control who can call the I/O server program? Yeah, we don't want developers updating production data. Well, developers should never be working in a production environment anyway. And remember that the I/O server is a program. And the I/O server must exist for a particular level of development, either development, test, or production, in the library with the library list. It's part of the database. And because the library list controls what table the I/O server is going to actually process, as long as you manage your library list correctly, you won't have that problem. Does that answer the question, Dean?